So let's see how we solve this. The first step is to change the integral into the variable z. So step 1. So say let I be the given integral from 0 to 2 pi cosine of 2 theta over 5 plus 4 cos theta d theta. So say this integral, we now want to change it into the general form, can be described as the real part of the integral from 0 to 2 pi. Now when I introduce the term real part of, then I have to have the I part in the integrand. So cosine of 2 theta plus I sine 2 theta the theta over 5 plus 4 cos theta. And by Euler's identity, I will be given by real part of so this is simply e raised power 2 theta I 5 plus 4 cosine of theta the theta. So the same integral can be written as real part of integral from 0 to 2 pi e raised power 2 theta I over 5 plus 4 cos is the same as e raised power I theta plus e raised power minus I theta divided by 2. And then this is with respect to theta. So I will be the real part of integral from 0 to 2 pi e raised power 2 theta I 5 plus, now you see this will be 2. So 2 e raised power I theta plus 2 e raised power minus I theta d theta. Now let z be e raised power I theta. So this implies that dz d theta will be dz over I z, and then e raised power minus I theta will be 1 over z, and e raised power 2 theta I will be the same as z squared. So therefore we'll have the integral I is real part of. Now when you fix now z to be in the integrand, now we are talking about the contour integration along the unit circle. So we'll have z squared over 5 plus 2z plus 2 over z, then dz over I z. You specify that C is the unit circle. So then let's simplify this. So we'll have I to be the real part of the integral along C. Now we are multiplying iz by every term. So I can say I have dz over I, then I multiply z by every term. So I'll have 5z plus 2z squared plus 2. Then I put here 1. And you see, I can remove I by multiplying by -1 in the numerator, negative I. So by doing that, I will be the real part of the integral along C. So then remember at this point, so this was not 1 but z squared from this point here. The numerator is z squared. So I'll have negative z squared I. This will be the same as 2z squared plus 5z plus 2 dz. So that's what we have. Now here, f of z is negative z squared I over 2z squared plus 5z plus 2. So poles are, you take the denominator of f of z and then you equate to 0. Now product is 4, sum is 5, numbers 1 and 4. So we have z 2z squared plus z plus 4z plus 2 equals to 0. Pair this. So z into 2z plus 1 plus 2 into 2z plus 1 is 0. So we have z plus 2, 2z plus 1 is given by 0. So this one is not hard to see that z is -2 and z is -1/2. So these are the simple poles of f of z. Now, if you draw a unit circle, this one, -1, -2, -1/2, 0, half. So you should be able to see that of these two values, only one of them will be within the unit circle. If you call this one 1, you call this one z2. So this way we have z2, but this way we have z1. So this is outside. So we don't care about this. We concentrate on this pole that is within the unit circle. So you say of these two poles, only z equals to -1/2 lies within the unit circle So therefore, we find the residue of this pole within the unit circle. Now residue at z equals to -1/2 by definition will be given by limit as z approaches -1/2 of z now plus a half times f of z. Now I replace f of z in the equation. So limit as z approaches negative a half, z plus a half. F of z is given by negative z squared I divided by 2z plus 1 into z plus 2. And you see, we can write this one as limit as z approaches negative a half, z plus a half times negative z squared I. Now, for me to have z plus a half, I factor out 2 here, and then I write z plus a half, and then z plus 2. See, when you open this, you get this first bracket. And by doing that, this bracket and this bracket cancels out. So we have limit z approaches negative a half of negative z squared I 2 into z plus 2. So this one direct substitution should work. So which will be negative a half squared I over twice into negative a half plus 2. Now, this will be negative 1 over 4I, and then negative a half plus 2, 3 over 2. So multiply by 2. So multiply this one by 2. So you get 3. So we'll have negative 1 over 4I divided by 3, which is negative 1 over 12I. So that's the residue. Now by Cauchy residue theorem, the integral along C of f of z dz is 2 pi I times sum of residues within C but because our case we only had one value within C or one pole within C, so this is just the same as saying 2 pi I times negative I over 12 and I times I squared, and which is negative 1 times this negative positive. So we have 2 pi over 12. This is the same as pi over 6, which is purely real. And actually, we're interested in finding the real value of the integral. So therefore, the integral from 0 to 2 pi of cos of 2 theta divided by 5 plus 4 cos of theta is the same as the theta is the same as pi over 6. So this is how you are to argue about that given problem. Thank you.